Hey everyone. Today we're diving deep into memoization in JavaScript. By the end of this tutorial, you'll understand what memoization is, how to implement it, and why it's so powerful for optimizing your code. Let's get started. So what exactly is memoization? Let me explain the concept. Memoization is an optimization technique where we store the results of expensive function calls. The key points to remember are: first, it stores function results; second, it avoids redundant calculations; and third, it improves performance for repeated calls. Now, why would you want to use memoization? It's particularly useful for pure functions, which always give the same output for the same input. It's great for expensive computations and functions that get called repeatedly with the same parameters. Let me walk you through how memoization works. First, we create a cache storage to hold our results. Then, before we do any computation, we check if we already have the result in our cache. If we do, we return that cached result. If not, we compute the result, store it in the cache, and then return it. Now let's look at the basic structure of a memoization function. Here on your screen, you can see we create a function called memoize that takes another function as an argument. Inside, we create an empty cache object. Then we return a new function that will handle the caching logic. Let me break this down line by line. First, we create a key from the function arguments using json.stringify. Then we check if we already have a result for this key in our cache. If we do, we return that cached result. If not, we compute the result using the original function, store it in the cache, and then return it. Let's see this in action. Here we have a slow function that squares a number. When we first call it with 5, it computes the result. But when we call it again with the same number, it returns the cached result immediately without recomputing. Memoization works especially well with recursive functions. Here we have a factorial function. The first call computes the result, but subsequent calls with the same input return the cached result immediately. When working with multiple arguments, remember that different argument orders create different cache keys. Here we see that adding 2 and 3 is different from adding 3 and 2, so both get computed separately. Let's look at a practical example. Calculating the 10th Fibonacci number is straightforward, but without memoization, calculating the 100th Fibonacci number would be extremely slow. Memoization makes this efficient. Let's compare the two approaches. Without memoization, we compute the result every time we call the function, which can be slow for repeated calls. With memoization, we compute the result once and cache it, making subsequent calls much faster. Here's a common mistake you might make. Trying to use an object directly as a cache key doesn't work because objects are reference types. We need to convert them to strings first. The correct way is to convert the object to a string using json.stringify before using it as a cache key. This ensures we can properly store and retrieve the cached results. Another mistake is trying to memoize impure functions. Here we have a function that returns a random number. Since this function gives different results each time, memoizing it doesn't make sense and won't work as expected. Here's a pro tip. Memoization works best with pure functions that have expensive computations. These are functions that always give the same output for the same input and take a significant amount of time to compute. Another important tip is to consider cache size limits, especially for large applications. You might want to implement a cache size limit to prevent memory issues. When using memoization, it's crucial to test your functions thoroughly. Make sure they work correctly with cached and non-cached results, and that the caching logic is properly implemented. That's it for today. Let's quickly recap what we've learned. Memoization stores function results to improve performance for repeated calls. It works best with pure functions and requires proper handling of cache keys. If you found this tutorial helpful, please like and subscribe for more JavaScript content. Thanks for watching.